This is a bit of a tricky question because it seems really math heavy and the wording is really scary and all of these answer choices kind of look the same because like g of 0 equals 3, g of 3 equals 0. Like to a lot of us that just makes no sense. This is really a vocab question though, and we can get this right without doing any work if we understand what they're really telling us here. So the main point is that if there's a polynomial function, some elaborate equation, and it has x plus 3 as a factor, well that means that we also know that negative 3 is an x-intercept, or more accurately, more helpful for us, that the point negative 3, 0 is somewhere on this equation, right? So there's lots of other points, but this one in particular is really helpful. In a second, I'll try to show you more concretely why that is, but for now, this is maybe just a thing to memorize, and so what would we do? Now we just kind of look for that point negative 3, 0 among our answer choices here. And basically, that's what function notation is doing for us. If it's putting a point, an xy point, in a slightly different format. And so the x is kind of in these parentheses, and the y is what it's equal to. So you'll notice the x is negative 3, the y is 0. That is true on Roman numeral 3, and that is the only answer that actually works. So if you memorize that, if you get that tight connection in your brain between the word factor and the word x-intercept, you're in good shape. But if you don't have that tight connection, we can still kind of finagle an answer here just by almost doing a little bit of an arithmetize, trying to understand what's happening at a deeper level. So what we could do is we could come up with an equation for g of x. And so we can make it something really simple that we encounter in math class a lot. Something like x plus 3 times x plus 2. It's a polynomial. It would become a quadratic if we, boiled it out. But for now, we want to keep it as factors because that's what we are given, right? We're given that x plus 3 as a factor, so we keep it in parentheses. And I've added a second factor just to kind of show what's going to happen when we plug in numbers. So the key here, though, is that you do this all the time in math class. You know this relationship between the word factor and the word x-intercept. The problem is you're confused because they're not giving you an equation and they're telling you it's an elaborate polynomial. Really doesn't matter. When we plug in these points, we're going to see that it's not always true that we get the values that they're giving us. So in Roman numeral 1, if I tried that, I would see g of 0. So, okay, g of 0 means let's plug in 0 for x. So that would be 0 plus 3 times 0 plus 2. 3 times 2 is 6. 6 is not 3. It does not work. So we can try the same thing now for Roman numeral 2. G of 3 is equal to 0. Well, that would be 3 plus 3 times 3 plus 2. We can probably see that's not going to be 0, but that is 6 times 5, which is 30, way off. So that's also wrong. And then if I did the same thing, though, for Roman numeral 3, I would see g of negative 3 is negative 3 plus 3 times negative 3 plus 2. So yeah, the part on the right, the other x plus 2 piece, is still going to give me a weird number. That's going to give me negative 1, but it doesn't matter because if one of these factors is 0, then the whole thing is 0. And so that is why the idea of a factor has a lot to do with the number 0. Is these ideas are intimately connected. It's why when we try to graph parabolas in school, we always want to find the x-intercepts. They're very important points. And so you got to kind of remember that, and this vocab is very important to remembering that. These words are intimately connected. It's a hard question because of that, but I just showed you 2 ways to do it, so hopefully when you see the word factor on a test, on an SAT, you are now aware that it has something to do with those x-intercepts that you're always finding in school.